so it will be later available at the IoT meetups on the YouTube. Um, Thank you for your time and welcome to the 39th meetup of the IoT Bratislava group. And today we will have one presentation. This is from a special guest, Nick Schmidt, who is a CTO on a New York-based startup called Blueprint Power. And this presentation will be, as mentioned in the chat, security-oriented IoT. So let me introduce our guest. Nick, during his career, worked on everything from the military sensor platforms to satellites. So he has a lot of experience in the IoT world. Um, his career spans the United States Air Force, this at DARPA, Boeing, and also started his own companies. At Blueprint Power, he's responsible for engineering from the software, hardware, that data, and the science behind all of the Blueprint Power does. In his time during this position, he has always included the security of the distributed systems and into the design. So let's see what the presentation he has prepared for us. And without further ado, please welcome Nick, and let's get to it.
All right. Very kind words. Thank you, David. So for those of you on the phone that work with me, this will all be a refresher. Hopefully you remember all of it. So I really normally don't like giving presentations virtually because it's really hard. I, number one, like to walk around and move with my hands. So I will do that here. It'll be on video for those around the table. But I'm very happy to have been invited. Thank you so much for having me. IoT is something that's near and dear to my heart. It's taken on a whole new life of its own, where the Internet of Things is just what we call distributed sensor platforms for many years. I like to call it the Internet of Terror now. I had to chuckle at their S in IoT stands for security. That is such a true thing. So I figured I would start with what the heck is Blueprint Power? Blueprint Power is a full service technology partner which basically is taking distributed energy resources and controllable loads at the edge and connecting them to markets. So you can think of this as we have a battery, we have solar panels, EV chargers, large controllable loads like chillers and CHP cogen units. How do you aggregate all of that distributed energy to optimize it, number one, against the building's load, and number two, to generate new sources of revenue and income? So that is Blueprint's mission. As you can imagine, to do that though, we've got a series of different things. You go from left to right here, we have some hardware that connects to all the various assets and controllable loads. We're pulling all of that data into a cloud, a very well run, well architected cloud, I might add. And then we're connecting it to markets and providing transparency to our users so they can see what their buildings are doing, where the energy is going, how is it making them money. So really, it's an end-to-end, if I can, IoT platform. What is a dig box? This is my favorite picture of the dig box. I'm old enough to where Dig Dug was new, and when it came out, so when we started trying to name this piece of hardware, our IoT gateway, if you will, the data ingestion gateway provided a really great way to connect it to my childhood. So Dig Dug is the game, Dig Box is the hardware. You can see an installation here. It's conduits. There's 3 antennas. Inside of the box is a software-defined radio, as well as a single board Linux computer and the ability to connect, control various assets at the edge. So that is Blueprint's IoT that a few people on this call have been integral into designing and deploying. So I wanted to make it catchy. So I was saying Raspberry Pis are the end of the world, and I felt real bad because I really love Raspberry Pis. If I think about how hard it was to do hardware before things like single board computers from the Raspberry Foundation came out, you know, we were sitting around with breadboards, we were sitting around tearing apart VCRs to pull capacitors. Those were the bad days. So Raspberry Foundation has really made it easy for us hackers and makers to do cool things. So I wanted to start. I really love the Raspberry Pi Foundation. Now let's go ahead and crap on it. So really the problem in the IoT space, in my opinion, is that everything is too easy. And what I mean by that is there are actual books, Raspberry Pi projects made easy. And what happens is engineers and geeks sit around and they say, man, I've got this really great idea. All the other solutions are really expensive, too complicated. I am geek, I will make faster. Like that's we all do this. We can all do it in a weekend. So we buy a little piece of Raspberry Pi and then we rapidly prototype it to prove out that idea. And then we sit around the table and we're drinking beer and we say, I told you I could do it in a weekend. But that's not really the whole answer. And that's not really what gets you to a profit. And so you end up with these hacky solutions. And I love when I walk into a site and I see something like what's on the right, controlling powers and doing relay. That's a beautiful thing to me as a geek. As somebody who has to build a business or is worried about the maintenance and getting these out into the field, it scares the crap out of me. So I would highly recommend down at the bottom, there's a required link. That sounds easy. I'm always reminded of when the iPod came out, somebody was like, oh, well, I can just install Linux on this little computer and I'll put a hard drive. Or when Dropbox came out, oh, that's just rsync plus SSH. Like we all do that, but it's not the whole story about the life cycle of what we need to be thinking about with IoT. So it works. What about the security? How will you update the outdated packages? How will you make sure that when you push software to it out in the field, it doesn't break? Is the data encrypted? Is it not? What happens if the device is hacked? And I apologize, it's like a million degrees in this room. Um, will the device deploy? Or where will the device deploy? So, putting a Raspberry Pi out in the field, will it survive the temperatures, shock and vibe? What if there's humidity? All of these things affect the performance of the device. And did you actually test it? Or are you just trusting that the brochure was right? That has bitten me personally many a time. So it's just something that we should always be thinking about. And then probably the biggest thing I see in the Raspberry Pi space is how many reads writes will the storage will allow for. You buy a cheap $10 SD card, you put it in, and then you write the operating system and your packages a few times, and then the storage dies. That is the single number one reason Raspberry Pis die out in the field. And then deploying one of something is really easy. Deploying two or three, probably still pretty easy. It's a Python script, it's a bash script, and you're good. What about when there's 100, when there's 200? How do you maintain them? How do you get people out to the hardware at the edge? What's the mean time between failures, the mean time to repair? Are there batteries? Can you change them? All of these things are, as we think about IoT as a solution and not just a rapid prototyping, is how do we build an ecosystem around these things? And then, as I always say, as everybody on the team that works around me here, hardware is hard. But don't worry, big companies figured this out, right? They're secure, right? Right? They're secure. No, I don't know how many. I was going to name some companies. I'll skip that part. But there are large companies that take the same idea. Instead of saying, is this a rapid prototype, they say, my name is X and therefore it's safe. And so you can't necessarily trust that just because you went out and bought something from a very large provider that in and of itself is a secure product. And then anybody that knows Shodan, uh, once again, please do not search for Shodan searches for Modbus devices, or you'll find weird things like this. There are 62,000 plus open Modbus interfaces on the internet. Not every one of them is controllable, of course, but many are, and many of them have exploits that are easily script kiddies could log in and destroy the device. And many of these devices are connected to power plants, relays, chargers, power systems, wastewater systems. So you don't want to show up on Shodan. Don't be that team. Crap. 62,000 devices. Bad news. So when we're dealing with all of these things, there's just so many examples. So I picked a few of my favorite, and in full disclosure, I drive a Tesla. I'm not defending their software engineering practices. But here on the left, we have a car that went out of cell phone range, and now they can't start the car because it needs to be connected to the cloud. And then what happens if there's no cell phone service? Um, the Tesla on the right can't drive because the software is too old. Very odd. Um, the thermostat EcoBees, which I do think you have over here also, there was an unplanned software outage. So it's 14 degrees outside and they can't modify their thermostat. Vacuum cleaners stopped working because an AWS zone went down. Doorbells stopped working because AWS went down. We have pulled so much of this tech into our lives that we're not thinking about What happens when the service goes offline? How long can it be offline? What happens if the communications goes down? And as engineers, though, we own that. And so when we deploy these little IoT sensors, we're opening up an attack vector into larger networks. So casino got hacked through a fish tank thermometer. That one I love. Um, I don't know if you need an internet-enabled fish tank thermometer, but cool. And then IoT botnets manipulating energy markets. So right now, I'm sure it's the same in Europe, but in the U.S. and other places, you register your smart thermostat when there's too much congestion on the grid. The utility reserves the right to come in and turn them down for you. So what happens if somebody hacks the utility or the controls platform that controls all the thermostats? You can begin to manipulate not only the physical world, but the financial world of energy markets. All of this is very scary. So, this is how the world ends. We are, in good conscience, putting all of these devices at the edge, connected to things that are critical to our lives, our vehicles, our home HVAC systems, the power grid, and there are no standards. There's nobody forcing mechanisms that say, thou shalt make sure this is secure. The European Union, much to their credit, has put forth some of the first legislation I think that's really pushing to make sure that these regulations exist. The US, recently, we actually blog posted about it, is putting in place critical infrastructure, and IoT devices connected to these things fall under critical infrastructure and will have to comply with these basic security principles. So, before all of that comes into play, us engineers, the people building and deploying these things, it sits with us. We can no longer be the people that sit there and deploy these types of solutions. We need to sit down and ask ourselves, and if we're sitting around having a beer, oh, I built this really cool thing, I want to sell it. Well, did you think about the security? Have you thought about how long it's going to last? What kind of fleet management tools are you going to use? We owe it to each other to sanity check these things before we let them out into the field. This community, this one in Bratislava even, has a responsibility to make sure that we're not deploying things like that. So I'm going to give you the list of the things that I think you should consider. Security. I mean, first and foremost, there's some wonderful regulations and policies and guidance from NIST. So I'm a little biased, of course, because I come out of the US, but NIST has put forth tons of great examples, how to secure checklists at the operating system level, at the services level. So go use it. It's free. We publish it. My hard-earned tax dollars, by golly, pay for that stuff. You guys should use it too. Maintenance. What do you do when something dies? What do you do when the board that you're deploying on is no longer available? What do you do when nobody in the world can buy microchips? Because that would never happen, right? And here we are. Software upgrades. This is one where, uh, was it the Fritz boxes in Germany that the embedded Linux version couldn't be upgraded? And so all of the cable modems in Germany had this huge issue, and they turned them into a botnet. I think it was mining crypto, of course, or something like that. How many of these little MikroTik switches and routers are running Linux versions with hard-coded root certificates? I mean, this is something that we come across all the time. So what is your off-ramp when that software becomes outdated? Hardware support. The Raspberry Pi Compute Module 3 drastically changed, and the 4 is a different form factor. So if you built your platform around some of these things, what's your plan? What's your roadmap to getting off these hardware devices? And then define to the community, if it's an open source project, which would be awesome. I love open source projects. Or to your customer, what are you going to support? Are they going to expect you 15 years from now to, be able to call and say, this won't connect to my Wi-Fi? Or are you going to say it's 3 years and there's a fee? Those sorts of things. You should always define what you're going to support. And then documentation. Don't let the tech debt get so big that you don't know how it works. Or there's no hope in ever considering how to support these IoT devices. Consider platforms. It is so tempting as geeks to sit down and say, I could build this better. The not invented here syndrome. Those crazy, so-and-sos didn't know what they were doing. I'm going to build this shiny new thing that's going to be amazing. Maybe. But if you're actually trying to get something out into the field and you're building a business or a solution around it, consider platforms. I'm not a big fan of tying yourself to cloud platforms like Azure's or Google's or Amazon's IoT platforms. But if I'm buying your device, I hope you're using them and not using nothing. So platform partnerships provide you some holistic platform, excuse me, support, and not only in security, you're pushing the risk around so that Amazon's going to be responsible for patching their services. And you know what? Maybe in the end, 2, 3 years from now, when you're a billionaire, you go back and you build it, and that's something you do. But probably don't start there. Would be my recommendation. Draw a clear line between R&D and production. You want to get your ideas out into the field and proven out as quickly as possible. And so pies are a fantastic, cheap, rapid prototyping. You can go to the store. Well, you probably could have went to the store recently or maybe a year ago and bought some. Now they're harder to find, but you have this really great platform to build ideas around. Prove it out, make sure it works, and then move to something more expensive. But always be thinking about that. This is my prototyping, this is my production. And so matching as closely as possible. So maybe your Raspberry Pi isn't going to sit out in the rain or survive 80 degrees centigrade. You can get something close to that platform though and then deploy that. Don't agonize over it though if it's not perfect. You'll never get to perfect. All right. That was my very quick talk around IoT security. I would love to answer any questions anybody might have, and happy to dive in. No questions is fine too. If you think of any, though, here's where you can find me. As David mentioned, I'm CTO for Blueprint Power. This is our corporate website if you want to know more about what we're doing. My email, my Twitter, my LinkedIn, my Mastodon, my IRC. Basically, I'm a geek. I'm connected. You can find me. So please reach out. I love what's going on in the IoT community. Between Blueprint Power and Makers, there's a really great group of engineers, I think, in this area that are doing amazing things. So I commend the tech community here for building this platform that not only is doing tech solutions but also putting out some really great engineers. So kudos to all of you. But if that's all, that concludes my talk, guys.
Yeah. Thank you very much for your talk about the security. If there are no questions, thank you very much for your time. But feel free, we can stay on and discuss if anybody has any topics. If not, I wish you a pleasant evening and thank you for visiting us.
Are there any questions? Maybe I have some.
Go for it, Anton.
I was thinking, what was the most horrible attack that you like really saw or
Oh,
you survived or
yeah. The one that jumps immediately to mind is I was doing a vulnerability assessment of some towers out in the middle of a desert doing something that we can't talk about. But I was doing a simple port scan, and I was sitting next to this tower, had a very large diesel generator from a very big manufacturer, and I hit the port and the IP address, and the generator turned off from a simple Nmap scan. And I was like, there's no way that was what happened. So we turned it back on, we flipped all the electronics back on, and then I scanned it again and it shut off.
no?
And it was very scary. I mean, luckily this was a decade ago, but I've seen that kind of stuff still out in the field where, how many people sit out there and port scan things and just shut right off.
Wow.
So yeah, I think that's probably the scariest that jumps to mind.
I have a similar story that I have read on the internet. Is regarding some French hydro plant, because there is a group of guys that are specializing on the showdown and finding out on unsecured devices, and they have found an access to a SCADA system that controls the hydro plant. So there was some politics involved. They were reaching out through the proper channels, and it took like 2 to 3 months before they took out the access from the French side of the hydro plant. Well, you could just dial it out. It would load it up in the SCADA system, and you could see the controls and everything, like how it's happening inside the plant on the internet.
Yeah, a lot of open VNC remote administration I find, and a lot of those systems, those BMS systems, are the vendor has decided they only support Windows XP still, and they'll be sitting out there with RDP or VNC unauthenticated. And so, yeah, there's lots of scary stuff out there. And Showdown, I like that team a lot because I think they're shining a bright light on those types of situations. But I go back and forth in my head. Is it better that it's so easy to find those because then you can shame those groups? Or is it really bad that that's so easy to find? Because there's only, I mean, 62,000 Modbus devices are sitting on wide open. Somebody has to go talk to 62,000 endpoints and figure out who owns them, what are they controlling, and then figure out a mitigation. And that's just a really difficult thing to do.
Yeah, I think that there was the modus operandi of that group. They were just scanning for the VNC open ports on the showdown, and they just tried login. If it was VNC for somebody who does not know, it's just the remote display that you can log in into, so like remote desktop on the Windowses, and they will just try to log in. And if there is a password, okay, it's at least protected. But a lot of them is just load up the SCADA system.
Yes, but brute force can be also used.
Yeah.
Yeah.
Yeah, one scary one I recently heard about was the SIM swapping.
The SIM swapping.
SIM
Oh,
swapping.
SS7 attacks. Yep.
That caused someone that he was using a Coinbase service that is like cryptocurrency exchanging platform, and there is a second factor via the phone, but really they exchange the SIM, they swap the SIM, and they could like sell all the account was really vanished. So it's all the money was vanished from the account. So that's,
Yeah, I could do a whole talk on just cell phone network security, which is its own separate thing. But there's a reason NIST said please stop using SMS messages as an authentication. Number one, they usually traverse the network unencrypted, so they're very easy to intercept. And number two, clone simming and finding those on the network are pretty simple too. And so that actually brings up a really great point of usually our going in position is to put a SIM card into this IoT device and put it on the edge because that's more secure. I'm not on the corporate network. I'm not on the Wi-Fi network. But then you're also inherently trusting that the SIM network, the LTE network, is secure. And so unless you're sitting down and doing network management and doing your due diligence, you run the risk of opening up your IoT device to those sorts of things. Um, and I've seen that with IoT devices that use the SMS messages as a command interface because it's cheaper. Sure. Well, now those command interfaces back and forth are unencrypted and easily interceptable. And so flooding those types of devices with SMS messages is totally reasonable and not that hard to do. So, yeah, be careful.
Yeah, it will be similar as opening up the internet banking over the HTTP, right?
Yeah.
Without the certificate. Yeah.
Nick, so you've mentioned the box. Could you tell us a bit story about how did you design the box and what were the main challenges you faced while you did like initial prototyping?
Oof. It's not. I can't share it, but I think a few people have seen what it started with and where it is now. And makers had a really huge part in helping us get to that latest design. But what happened is data was hard to get access to from the grid. It was non-existent. So how do you feed your models and your databases with what the building's doing, how it operates, what the assets' performance are, if you can't get access to granular data? So originally, this was supposed to be a very temporary, like we bring it out to the site, we plug it in, we wait for a week or two, and we pull it out. But then we started realizing that the barrier of entry of those types of devices, number one, were either very costly, and number two, quite often were just not secure at all. And so we felt a responsibility to ensure that the device we put at the edge was secure. And so as we were doing the initial designs, I started actually with a BeagleBone. I don't know if anybody knows the BeagleBones, because they at the time had on-chip crypto. So this would have been like Raspberry Pi 2-ish days, 3 days. So that's changed a lot since. But we started on the BeagleBone. We then migrated over to Raspberry Pis because I was having trouble getting BeagleBone, so we went out and bought a bunch of Pis. And very quickly started realizing that, hey, there's a product opportunity around this. And it's not that the dig box is exceptionally amazing and not, this one thing that can do all of this and it's one of a kind or something like that. What makes the dig box and that design special is that it's cheap, low cost, and easy to connect to our cloud. And so we own from end to end the data ingest, the command and control into our cloud. And that was really important. So very quickly after we realized there was a product, we started doing a market analysis for how do you get a rugged Raspberry Pi-ish type hardware. We were looking for industrial-based control systems. And luckily there's some really great companies that have sprung up. Belina, there's the team in Germany whose name's escaping me now. Revolution Pi guys, that's the one. And so there's these neat little ecosystems of industrialized Raspberry Pi-like hardware. And so we quickly transitioned to that, and here we are 3.5 years later or so. It started off as a weekend project. Robin Beavers, our CEO, kind of put this challenge out there. We got to get data from these buildings. How are we going to do it? We'll figure it out, and came back a few days later after the weekend, and we had our first kind of prototype. We went through a ton of various iterations. We played with Ubuntu Core. We tried rolling our own Yocto Linux builds, and then ended up on where we are today. That I think's been great. But that same idea of sitting around, like, how are we going to manage this device? How are we going to make sure it's secure? How do we push software updates to it? Those are all things that we considered early on to drive our designs.
Yeah, thank you.
Maybe you mentioned that don't start with the own platform. In a blueprint, there is an own platform. So was there some kind of consideration of platform that is already created, or to the decision?
So we originally started thinking about, because Dell does a really great IoT gateway. It's an x86 based system, but Robin had this vision for connecting thousands of buildings, and you didn't want to have something with that type of size, weight, and power swap, as we call it in the field, sitting at the edge. And so a lot of those solutions based around the x86 architecture, the rugged Intel Atom CPU classes, are all Windows 10 IoT type builds. And so by buying into that platform, you basically tied yourself to Azure and the Microsoft ecosystem, which is not a bad ecosystem. It's just I'm not a Windows person or a .NET team, so we looked at some of those platforms originally to include things like Ubuntu with their Ubuntu Core and IoT setups, using, I think they call it Launchpad or something like that. Landscape. So we had looked at a lot of different platforms. The European Union does a great one through Minder, which I think Minder is now kind of rolling out of the academia into more of a commercialized product. But we sat and really it turned into loading 5 or 6 Raspberry Pis with each different type and figuring out what worked best. Each one had their challenges, and we picked one that we thought worked well at the time, and ended up kind of very quickly not. So where we've landed today, I think, has been super useful. But it took probably, I'd say, 6 to 7 months of testing. And what you run into is, how do you deploy your code and then update your code at the edge? And not to, I really like the Ubuntu team, and I really like their solution, but it's all Snap based. And Snap has its own benefits and downsides, but that's not the way we were building a software platform around. So our tech didn't really fit into the Snap-based ecosystem, but Docker containers did. So we looked for something that could deploy Docker containers, and we've always been containerized at the edge, and that's has the downside of being a little bit of a performance impact and more complex networking, but also provides us the ability to quickly push new builds, spin up redundancy, and really assisted with our rapid prototyping, I would say. So there's certainly pros and cons to every solution, um, but I think containers at the edge are a very beautiful thing. Not sure I buy into K8 at the edge yet, but there's some really interesting things going on in the CNCF world, which is probably a little bit of the bridge of the IoT and what's going on in the cloud worlds. But I really like that idea of Docker at the edge, and so that's the solution we ended up on.
Maybe then I didn't understand. There was like your slide. There was written that don't start with your own platform. I mean,
Yeah.
the cloud. I thought that
Yeah.
you mean cloud based platform.
Yeah. So what I meant by that is when I started the weekend project um, with one of the other engineers, we fell into this trap of, well, if it's a Docker container, what if we just set a cron job that automatically does a Docker pull? We'll set up a Docker repository or a registry. It'll automatically push the Docker container there. It'll pull the Docker container down. Oh, well, now I've got a way to update. What if it fails? Okay, we'll write another cron job that says, do a health check of the Docker system to then verify if the new image build worked. Okay, yeah, now we got 3 cron jobs, and now we've got a Docker registry. And then we're like, well, what if we need to update the cron job? I know, we'll set up a Git repo and we'll SSH into that and then pull the latest cron job. And before, a few days into it, we're like, this is stupid. Like, we're building band-aids around a solution. And as a small team, I call them innovation coins. You get to spend your innovation coins once. And so instead of spending our innovation coins on building a platform that does all the cron jobs and the atomic updates and operating system pushes, we put that off to the side, found a good solution, a platform that we could build on, and then focused on what we do well, which was building software to do controllable loads and data ingest. That's what I meant.
There's a question. You can unmute the microphone and let me show it. So, what impact and what changes?
Okay. Great. Thank you for writing it out. That makes it a lot easier for me to remember. So for everybody who can't see, there's a chat window that has some messages. So I'm just going to kind of work through this question here. The hardest thing the pandemic had to blueprint is twofold, I would say. Number one, production of dig boxes became more difficult because the facility that assembles all of our parts was also under COVID restrictions. So they could have 3 assemblers versus 10 assemblers, and they had to be this far apart. And so that slowed down things inherently. And then once you have a dig box and you want to go to the site to install, at least in New York City, where a lot of our customers are, it was very uncertain. Can you enter the building? Can you not? Are you allowed into this part of the room? Do you need an escort? Is the escort able to be there? Do you have the right PPE? Um, so we found a lot of issues in just getting our hardware deployed. Um, I will say now, the security side, I think, in many ways, COVID was a blessing in that because we couldn't deploy hardware as quickly as we hoped for, it gave us time to really sit down and say, well, we had this tech debt and we had this thing we wanted to try. We can't get it into the building right now, so maybe let's spend some time really finessing that feature set. And so I think we took advantage of that downtime to really accelerate feature development. Um, but now you kind of pointed out the chip shortage. That is just a massive impact on the industry as a whole. I'm from Michigan, the state that looks like a hand, where Ford and GM and all the auto manufacturers are. It's like Slovakia, but in the States, right? Um, and when I was going to the airport, there are thousands of pickup trucks and cars parked because they don't have the chips to put into them to sell them. So there's just fields full of cars. Um, that doesn't help my situation at all at Blueprint, but it did make me feel a little better that some of the largest auto builders in the world can't get access to this hardware. We're in good company, I suppose. And what did you get out of it? Well, I got to stay home in northern Michigan, which was great out of COVID. I think it really helped our team. I know this is not IoT related, but we'd always had this remote first type of stance as a company, which sounds really great until holy smokes, we are all remote first. What policies broke? How do we get to be more asynchronous in our development and our communication? And then, it ran into once things slowly started to open up. I was driving from northern Michigan to New York 14 hours to go to the site because I couldn't fly to figure out dig boxes. And David and I would be on the phone with the time difference and me driving back and forth and getting the dig boxes ready for installation. So there were certainly some personal challenges in just how we could get into to getting the hardware ready to deploy. But Blueprint had a really tough year, I think, as most startups did, but we survived it, and I think really took advantage of that downtime. And so, I always try to find the silver lining on things. So that's my silver lining. Great question. Thank you, Thomas.
So guys, I got one. I hope you can hear me well because my mic is notoriously bad. But so, Nick, could you maybe describe the tick box from a tech perspective? Why don't you just try to connect to the building management systems remotely and pull data from there? Why don't you just parse consumption data from the utility companies? Did you experience show differences between the data you gather and these systems and what do these systems provide? Were there any maybe discrepancies in this data?
Yeah, a great question, Peter. So I'll start with the utility side. Smart meters here are very similar to the smart meters that are being deployed in the US in that they provide an interval of consumption data, and it's usually a running interval. So it's anywhere from 5 minutes, but usually 15 minutes, sometimes an hour. And so if you're actually looking to understand the load of a building and the types of use cases, 15 minutes is bare minimum. An hour or daily or monthly consumption is almost worthless. So assuming the building had 15-minute interval meters and you wanted to go to the utility, how do you get the utility data? Well, in the States, that's a very difficult thing. We have a standard called the Green Button Connect, GBC, that was supposed to have made all of the utilities API interfaces the same. That is not true. And every single one of them is different. So you found yourself having to write a connector to every single utility to pull that data out and store it. And so that just didn't provide us an easy way to scale. So from a utility perspective, number one, the fidelity of the data is not that great. And number two, you'd have to write a Con Ed utility connector, and then a National Grid utility connector, and then a Consumers Energy utility connector. And so that's really hard to scale a company around when there's so many different interfaces to extract data from. And then your second question, I think, was why not just connect directly to the building management system? So this is a misconception I had coming in from outside the energy space 4 years ago. I thought every building management system would be similar. And I guess what I mean by that is I didn't expect there to be BACnet and then BACnet Plus and then like Modbus, but this is the, you know, Nick Schmidt version of Modbus. I was like, well, wait. These are standards. How are there different standards for the same protocol? And so what I found is that each building was a little different. And then you would think that if you owned lots of buildings, that they would all share a very similar system. That's not the case because the way real estate works is I buy this building, I hold on to it, maybe I sell it in a few years. And so you get, even within a specific customer, multiple types of building management systems. So now you're in that same kind of utility issue. Now I need to write for 10 different systems how to pull building management systems in. So let's assume that was a good idea and we put in the time. You're now connecting building management systems running on Windows XP to the internet to pull that data in. And in good conscience, we couldn't do that at Blueprint. So something had to provide a mitigating security umbrella, which became the dig box. Which is not to say, so the way Blueprint thinks, if there's systems at the edge that meet our security requirements, we're happy to connect to them and ingest and use that data. Nothing says we wouldn't. I've never seen one yet. So if anybody's looking for an IoT business idea, IoT secure building management systems are probably something, because they're just very hard to find, and that makes sense because you normally have this air gapped network with a SCADA network connected to this one building management system, and then a separate network where the corporate IT sits. And so the scary thing is just bridging that over, and connecting it to the internet. And I think right now that just puts so much risk on the building as well as Blueprint's business. We're connecting distributed assets at the edge. Something hacks that puts us at risk as a company. So it was just safer to inherit that risk and then build a more secure way to connect it. Thanks, Peter.
Thanks for the answers.
Well, may I ask you? I remember you showing us this post or photo where you had this home-based Raspberry Pi project for automation for like the door for a chicken, and I guess that you have more of this kind of Raspberry Pi projects, home projects. And what project do you consider like the most interesting in your opinion?
Um, yeah, so Samo's kind of alluding to it. I live on a farm in northern Michigan, so if I'm not sitting down with the team engineering, I'm out taking care of chickens and cows and things like that. So I got tired of having to shut the coop door. So a photovoltaic sensor on a Raspberry Pi with a servo to roll the door up and down saved me from having to go out at night. And so usually I would say my Raspberry Pi projects in my house are laziness induced. So don't want to wake up to let the chickens out. I can figure that out in tech. I wouldn't try to sell it. It's connected to my home network. It's a little Python script, you know. But usually it's around things I'm interested in. I really like software defined radios. So I do a lot of projects around RF spectrum analysis, whether that's being able to track airplanes flying overhead, or I live very close to one of the Great Lakes, so being able to track the AIS receivers from boats to know what boats are out there is really interesting to me. But yeah, it's normally around me being lazy or me being curious, and that's usually what my Raspberry Pi projects are.
Cool, thanks.
Sorry, it was a really great question, Sam, in the sense of that farming equipment is becoming very IoT centric now. The tractors have sensors for detecting where the lanes are of corn, and GPS to know how to automatically route the tractor as they're going around. And so you're seeing this weird automation in the farming community, which is really great for me. But there's this downside where, at least in the States, a lot of the tractors are becoming locked. And so in order to fix your tractor, you have to hack the device. And so it's a weird thing happening in the farming space with IoT. All right, Peter, what was the last IoT device you bought? Oof. I can't even think of the last IoT device I bought. I have some Arduinos that I was doing power relays on for fun. I think that's probably the last one. Oh, I did buy a smart sprinkler system. I have sprinklers in my yard to water my lawn. That's IoT enabled. That one's pretty cool. I'm a big fan of Home Assistant and Open HAB ecosystems, for home automation stuff. So my RV, my camper, my caravan, was getting too cold, so I put temperature sensors that I routed through my gateway, so I get an alert when my camper is too cold or too warm. But yeah, so I haven't really bought anything specifically. This darn working thing and building a company's kept me a little busy, so I haven't had as much time to play. And number two, what can't you wait to get on the market? Any gadget, tech, specific RF protocol? Um, I think there's a lot of disruption in the building space, and not just the home automation space. I think home automation is kind of, I don't know, there's only so much you can do, and there's too many dead devices, and I don't know. Home automation is not so exciting, but on the building front, I think there's a lot of potential for using wireless sensors, in place of very expensive building management systems, PLCs, SCADA networks. So I think I'm quite excited to see what happens at the edge and buildings and industrial sites because any data collection and automation that can happen at the edge only improves Blueprint's business and being able to optimize it. So I'm really excited about that.
What 5G? Is it coming?
5G.
Is it coming?
Yeah,
Here already.
yeah. It wasn't 5G, it was WiMAX. If it wasn't WiMAX, it was X25. I mean, there's so many like RF protocols that are supposed to revolutionize IoT, and I think 5G unlocks a lot of potential in dense, high bandwidth applications. The thing that's maybe a little difficult with 5G and some of these newer radio protocols is they're battery hungry. And so, if you're looking for high long term usage, do you actually need those data rates? Is probably the first question to ask yourself. So, I'm excited that people are talking about cell phones everywhere. I'm cynical in the sense of I don't know how that'll actually be implemented, or do I want that to be implemented? Any other questions? Can you share with us your vision for energy markets in the future? Oh, yeah, that's a long one. Um, so I see energy markets are going to get more real time. So right now the energy markets operate in these day ahead markets for the most part, or sometimes it's a quarterly or seasonal, and that doesn't really match the constraints of the grid. And that grid can be natural gas or it can be electricity, but I see this world coming, and it actually has come in some places where there's dynamic congestion time of use rates, and I think that's going to be a big thing that happens. Um, you see it in California and Arizona already, where the price of a kilowatt or a therm of natural gas will be based on the real time dynamics of the grid. So instead of us going, oh, it's going to be really hot or it's going to be really cold, so the price is going to be higher tomorrow, we'll see minute by minute changes to that pricing to help better encourage different things from people. And so I see this real time data and status of the grid also playing into the real time capabilities of the house. There were some really interesting presentations from LG, their home area network, their HAN protocols that they're deploying in some of their German appliances. Where do you actually want to run your dryer right now to dry your clothes? If you wait 3 hours, and it'll save you 10 euros, and we'll schedule that for you. And so being able to tie that source of information to the real time pricing of the grid, I think will really finally truly connect generation and consumption in ways that it hasn't been able to thus far, just because there's a lack of data and a lack of insights into what's going on. So more real time, more dynamic, and more distributed. Um, Solar panels are coming down in prices, batteries are coming down in prices. So I think this idea that there'll be this giant central power plant somewhere that feeds every home, I think that goes away. People are going to be able to do their own generation at the edge through batteries and solar. I think that'll be a huge boom for the industry as a whole. But yeah, that's a mini hours conversation on grid dynamics.
Are there more risks when it's distributed? Because as it was already, I think in January, there was a shortage of energy coming from, I don't know, from Croatia or where. Is, and went through Austria, where all the distributed resources somehow was actually disconnected because there was no wind, there was no
Yeah.
sun.
Yeah, I mean, so as IoT engineers, if we think back to the earliest days of network topologies, the idea was always to have the redundant networks. So whether that's in routing protocols with OSPF, finding the shortest path and making the best decision about where to route the packets. I see a lot of analogies to the energy markets, and that right now that was more of a single point of failure going through a single country, through a single pipeline, through whatever it may be. And so I think a distributed grid helps offset some of that risk. So, for example, Texas, that's the one near and dear to my heart. They didn't put wind or winter protection on the wind farms, and so no wind farms, no energy problem. And if every home in Texas had the ability to do solar and storage, Texas is very sunny. That impact from having a lack of centralized generation wouldn't have had such the effect it did. Um, but regulations need to change, at least in some U.S. states, and I think some European countries. Your solar doesn't actually connect to your house; it's just exporting to the grid, and then you're getting a credit for how much energy your solar panels are producing. But the electron is not actually supplying your home, even though it's sitting on your house. It's in essence leasing your roof space, and so that's a little bit of a shift to say, well, no, no, I actually want to consume that electron, or I want to store that electron. And so inverters that are becoming grid formed and the ability to go island mode and off on grid, I think that's also so as that technology comes more mature and as regulators begin to recognize that, your home becomes its own little power plant, or at least that's the vision for the future.
Yeah, and what about the carbon footprint of all those batteries, solar panels, and
Yeah, um, batteries. We're just getting to the point where they're starting to be affordable enough that people can buy them, and I don't think there's a really good story right now around the sustainability of batteries and recycling. There's some really innovative companies. There's one out of Norway that jumps to mind. I can't remember the name that are taking Nissan Leaf batteries and Tesla batteries and basically EV batteries, refurbing them to make them ready for less dense situations. Where in your car you don't want to have a 30-meter long car so you can have all the batteries. But if the battery is less efficient, but it's sitting in my garage or in my backyard, I don't care. But yeah, I think we haven't begun to accept what the sustainability impact to distributed energy is. And I think that's a challenge and an opportunity for the industry as a whole. Um, right now we're on 10-year warranties really for batteries, and those usage curves don't really reflect what the future probably will bring. But I remember when solar panels were 10 years, and now they're 25 years, and really it's like 35 years before they start to degrade in performance. And so I think the technology will get better, but yeah, we have a sustainability question on what do we do with this e-waste, if you will, after it's done.
I got one more.
What do you
Yeah,
say?
I got one more, if I may. I know
Okay.
this relates only maybe remotely to IoT as a general, but what's your opinion? What do you think about using machine learning at the edge? Should we sacrifice the simplicity of our IoT gateways to just rely on less on the connectivity and cloud accessibility and all these cloud solutions, or should we just really push it to the cloud?
Ah, I get asked this question a good bit. Um, yeah, there are pros and cons to both. I think in a dynamic marketplace, not being connected to the cloud is a disadvantage because there's so much information that comes in from external data sources that it would be unreasonable to try to pull all of that data into a gateway at the edge of the network. So I think in some situations you have to have a cloud component, and especially for Blueprint when we're connecting to markets, there's very discrete single connection points from our platform to a network or a market. And that would be unreasonable to expect the utilities or the grid operators to have a million of those at each household connecting to that edge device. So I think there's probably some, with everything, moderation. But I do think IoT needs to get better about local control first. What I mean by that is it bothers me that when I send a command, it has to go all the way to the cloud and all the way back down, and it's sitting right here. And that affects me in northern Michigan because we lose power a lot. And so my internet will go down, as people who have to attend meetings with me know. And so when I can't control a device because it's not connected to the internet, like those examples I gave of the car not being able to start, I think that's an issue. And so as IoT engineers and architects, we need to be thinking of what degraded mode looks like. Ideal mode, operational mode, maybe is cloud connected, but what is the subset of features that I'll provide in a degraded mode? What does that architecture look like? And by using things like MQTT, where there's that message bus that you can publish on, that opens up the possibilities to doing local as well as command, or as well as cloud connected, or having a REST interface that provides a very simple on-off mechanism or a safety button even. I think that's all doable. It's just where your priorities sit and the development of that, because it does take extra engineering effort. So I think it was 7 o'clock was the cutoff. Any last questions or comments? I'm going to need to run.
Right. Thanks, guys. Have a nice evening.
Bye. Thank you.
Bye.
Bye. Thank you, Nick, for the presentation. Bye.